Dear student, today we see that the percentage composition as well as the empirical formula and molecular formula. Okay, now we go to that percentage composition. Actually, the percentage composition in order to get in that organic molecules or any molecules. Okay, here I taken the organic molecule. In order to get in the organic molecules, it's organic molecules. It contains molecules. It contains majorly the carbon and hydrogen. Okay, so the particular molecule, the how much percentage of carbon are presented, and similarly the how much percentage of hydrogen are presented. So like that we can easily finding the following formulas. Okay, so now this actual the mass percentage. Okay, mass percentage is equal to the mass of an element, mass of elements in 1 mole. Okay, whole divided by, that is a molecular mass, or that's a molar mass into 100, because we can finding the percentage. That's why whenever that percentage is finding the lastly given or input on the int of 100. Okay, so the mass of an element in 1 mole. So here is must be known, there is a mass of an element, mass of the finding element. Okay, mass of the finding the percentage of mass of an element. Okay, that's enough, mass of the elements. And the second category as a molecular mass. Okay, so these two is very very essential. For example, see here is a methane. Okay, here the carbon of its mass as 12 gram. So 1 mole of methane is containing 1 carbon. So actual the element of carbon, it has 12 gram, and hydrogen its mass equal to 1 gram. Okay. So and also the methane of its a molecular mass, the sum of the atomic masses of the element of molecules. Okay, so that is why the sum of the atomic masses is equal to molecular mass. Here carbon has a only 1 carbon, so here as a 12 plus a, and it's a 4 hydrogen is there. Each hydrogen is a 1, so 4 into 1 is equal to 4, so 12 plus 4 is equal to 16 gram. So this was the molecular mass of methane. Okay, we know that the methane of consisting carbon of mass and hydrogen of mass and the whole methane molecular mass. So that's why we can go to that carbon of its percentage, that is equal to carbon in the 1 mole of methane is consisting only 1 carbon. So there is a 12 divided by, there's a molecular mass of methane, that is 16 gram. So there is a 16. There is percentage means there is a 100. Okay, so we can simplify this. There is a 3 by 4 into 100. So 4 25, there is a 100. So there is a 25. So 3 into 25, actual, that is a 75 percentage. Okay, so in generally methane is consisting 75 percentage of carbon. So the methane is only carbon and hydrogen, only two types of the element are presented. So that's why the percentage of hydrogen, that is equal to 100 minus as 75. So what we can get, yes, there is a 25 percentage of hydrogen are presented. Okay, for example, the nitrogen percentage is finding the compound, actually urea, NH2 C double bond O NH2. Okay, so nitrogen percentage, here this is a 1 mole of urea. This urea is consisting the 2 nitrogen atom. There's 2 nitrogen atom. So that's why 2 into 14, that is equal to 28 gram. The 28 gram of nitrogen is there. So this for the nitrogen of weight, and actual this molecular weight here, there is a 2 into 14 is equal to 28, and hydrogen is a 4 hydrogen is there. So 4 into 1, that is equal to 4, and carbon is 1 is there. So 1 into 12 is equal to 12. So oxygen is a 1 is there. 1 into 16 is equal to 16. So we can add this. There is 10, 14, 20. So 0 remainder 2, 4, 6, 7. Okay, so this for there is a 7. Actually once more, it's a 4 6, oh sorry, this is a 6 gram. So actually this is a molecular weight of urea. This is molecular weight of urea. So we can go to that nitrogen percentage here. There is 28 divided by, there is a 60 into 100. So 0 is cancelled out. So there is a there's 3 times here, 1 4 times. Okay, so this 1 4 divided by 3 into 10, we can get in the answer around, there is a 45. Okay, so there is around 45 percentage of nitrogen is there. 45 percentage of nitrogen is there. The next we can finding the nitrogen percentage, nitric oxide, that is NO. The how much percentage of nitrogen is there. So here nitrogen is 1, so nitrogen percentage is equal to 14 divided by, Here there is a molecular weight, that is 14, 16 added 10 remainder 1, there is 30. Here is a 30 into 100, 0 zeros cancelled out. So we can go to the solve in this value, we can get that is similar like of 45 percentage. Okay. Okay, so the next, the ammonia of ammonia, it is how much percentage of nitrogen is there. Nitrogen of its percentage, here is only one nitrogen, so 14 divided by this mass, actually 14 plus 3 is 17 into as a 100. Okay, so we can get in this answer, there is a around 82 percentage. Okay, so there is a simple, it's a very simple topic, the how much percentage of element are presented in that particular molecule. Okay. Okay, next we go to that empirical formula and molecular formula. It's a uh, formula empirical formula. Actually, this empirical formula is a simple whole number ratio of simple whole number ratio simple whole number ratio of molecular formula. Okay. Okay, so for example, in the case of glucose or whatever, that benzene, for example, there's a benzene, this benzene is consisting C6H6, so it's a simple form CH. So this for that empirical formula, this for that molecular formula. Okay. Okay, so the next, the molecular formula, there's a molecular formula, it's nothing but there is a actual number of atoms, there's here, there's actual number of atoms in the molecule, actual number of atoms in the molecules. Okay, so that is for that molecular formula. For example, C6H12O6, it's for that glucose for molecular formula. Okay, glucose of its molecular formula, so it's a simplest form, what, there is a CH6O. So this for that empirical formula. Okay, so the empirical formula is nothing but the simple whole number ratio of molecular formula, that's for empirical formula. Then the molecular formula is nothing but the actual number of atoms in the molecule. So in the case of glucose, the consisting 6 number of carbon and 12 number of hydrogen and 6 number of oxygen atoms. Okay, so the some elements of simple ratio are based on the empirical and molecular formula. For example, that is a molecular formula, here is a empirical formula. See, the H2O2, it's for nothing but hydrogen peroxide. Its empirical formula what? Yes, H2O. Yes. Then naphthalene, there is a C5 and H4. So this for that or C10, C10H8. So actually this empirical formula what? C5H4. Okay. So benzene actual molecular formula C6 benzene, C6 H6, here as a CH as empirical formula. So like that, the simple concept, the simple whole number ratio of molecular formula as a empirical formula, the actual number of elements in the molecule, that is equal for molecular formula. Actually, the molecular formula, that is equal to n into empirical formula. So this formula is very important. We finding that empirical formula and n, we can multiply these two, we can get that molecular formula. Okay, so here n is equal to, for there is a nothing but based on that empirical formula mass as well as there is a molecular formula mass. The n is equal to empirical formula of mass divided by there is a molecular formula of mass. Okay, so this is a n value. And also sometimes the question are given in the vapor density. So that's for that time, actually molecular mass is equal to 2 into vapor density. Okay, so this one of the formula is very useful for that molecular mass or molar mass. Then only we can go to finding the n value. Then after that finding n value, we can go to n into empirical formula, we can get in the molecular formula. Next, there is a rules for the finding the molecular formula. Rules actually, sometimes they have given the question or percentage composition. Okay, it's a percentage composition is converted into gram. Okay, grams. It's nothing but we already uploaded in the previous video, especially concentration terms. There is a percentage composition. For example, I need the 2% of magnesium chloride solution. Okay, magnesium chloride solution. For this solution is prepared the 2 gram of magnesium chloride in 100 ml of water. Okay, so this solution is nothing but as a 2% of solution. So that's why I am telling here, the question if they have given in the percentage, we can take an for that value is directly in the gram. Okay. Okay, the next this weight or gram into, there's a gram, actually there is for that weight. Okay, so this is from this weight we can finding the moles. Okay, moles, we can finding moles of each element, moles of each element. Okay, okay, so the next, from that mole value we can divided by the smallest mole value, smallest mole value. Okay, okay, so then we can get in that empirical formula. Then the empirical formula mass, actually there is a molecular formula is equal to n into empirical formula. Okay, so here there is a n finding formula, there is n is equal to what? Yes, empirical formula mass divided by there is a molar mass or molecular mass. Okay, so this is a simple rules or small steps finding the molecular formula. Okay, for example, one question, a compound containing 4.07 gram of hydrogen. Okay, hydrogen, and there is a 24.27 percentage of carbon. Okay, okay, the next, there is a 71.65 percentage of chlorine. So what is a molecular formula as well as the empirical formula? Okay, so we can go to that very easiest way finding the molecular formula as well as a empirical formula. Okay, so here initially I written here carbon, hydrogen, and there's a, or the that is a vertical way, there is carbon, here is a hydrogen, here is a chlorine. Okay, so initially this carbon, how much percentage is there? What? It's 24.27 percentage. We can go to the percentage into gram conversion. Okay, so then hydrogen here, hydrogen how much percentage is there? Yes, 4.07 percentage, so we can convert that to gram. Then chlorine, there is 71.65 gram. Okay, so this actually the element of weight, from this given weight we can finding the mole. So mole finding, there is n as a mole. How we can find this mole? That's 24.27 divided by carbon of mass, what? There is a 12 gram. So we can approximately cancel out, there is a 2. Okay, so 2 12 as a 24. And similarly here hydrogen 4.07 divided by 1, actual hydrogen of mass as a 1, so that's why given divided by 1 we can get in that 4 approximately as taken. And here this chlorine as 71.65, here the chlorine of mass as the 35.6, so it's approximately is cancel out what? There's a 2. So here there is a 2 and 2, there is a actual least value, we can go to that the least value divided by other values. So that's why here 2 divided by 2 cancel out as a 1. Here is a 4 divided by 2 is cancel out as 2. And here as 2 divided by 2 that is cancel out as 1. So here the carbon as a 1 and hydrogen as a 2 and the chlorine as a 1. So this for that empirical formula. Okay, this for that empirical formula. There is CH2 and Cl. That's for empirical formula. Now we can go to the molecular formula finding. This molecular formula, initially we need to that the n value. Okay, so there is empirical formula here, there is CH2Cl. Okay, so n is equal to empirical formula mass divided by molar mass. So what is a molar mass? That molar mass are given in the question. That is actually the molar mass is equal to, here there is a 98.96, that's a gram. Okay, so this for that molar mass. So itself with ourselves we can finding that empirical formula of mass. Empirical formula CH2Cl. For this one carbon as a 12 plus 2 hydrogen means it's 2 plus that's chlorine as 35.5. Okay, then we can add these two, there's 20, sorry, there is a 14 plus 35.5, so we can get in that there's a 5, then 9, here there is 4 and 5 or 4. Okay, there is a 49.5 gram. Okay, so actually there is a empirical formula mass divided by, actually sorry, here there is a molecular formula of mass divided by there is a empirical formula of mass. So n is equal to, what is the molecular formula of mass? Here there is our molar mass, there is a 98 divided by 98.96 divided by 49.5 is approximately is cancel out what? 2 times. Okay, so here is a n is a finded, so the molecular formula is equal to 2 into empirical formula what? CH2Cl. So we can multiply for into inside the molecular formula is equal to C2H4Cl2. This is the answer. Okay, next this given data, what is a molecular formula? So here carbon as a actually 80 gram and hydrogen actually 20 gram. So from that data we can finding the mole. Here is a mole, there is a 80 divided by 12. Here is 2 divided by actual height as a 20 divided by what? There is 2. We can cancel out this, there is 10 times, we can cancel out this. Actually 512 or 60. So 612 or 72. There's 612 or 72. Around there is a 6. Okay, so 612 or 72. Remainder there is 8 is there. So we can take as a 6 here. So this 6 we can take around there is a here the hydrogen as a 1, so we taken as a 20 here. Okay, so there's 6.6 here answer. So these two here 6.6 as a least value, so that's why 6.6 divided by 6.6 cancel out as 1, and 20 divided by 6.6 we can cancel out, there is a 3 times. So here empirical formula, carbon as a empirical formula, carbon as 1, hydrogen as a 3 times. Okay, so this empirical formula of mass, there is a 12 plus 3, that is equal to 15. Okay, so we can go to that n is equal to, there is a molecular mass or molar mass 30 divided by the empirical formula of mass as a 15, cancel out as 2. So that is why the molecular formula is equal to 2 into CH3. So what is the molecular formula? Yes, it's a C2H6, that's the answer. Okay, so actually this topic is very very simple, easiest question asking in the NEET and JEE. If you like in this video, you can subscribe and share your friends. Thank you to all.